Cool. So thanks everybody for tuning in, whether on YouTube or in the audience. Thank you so much, Noah, for joining and hosting this. Today we're going to be going through something pretty simple, honestly. It's something Noah has reinforced shouldn't be intimidating. We were joking about how there's like 2 main lines of code really that you need to know, and from there it's pretty easy. But it's a crucial step nonetheless in making Web3 usable and adoptable. And that's building the front ends for these awesome smart contracts and on-chain dApps. Front ends meaning the actual buttons and interface that you look at, your UI, and how the user is able to interact with the contract in different easy ways. And in Web3, and particularly in Cosmos, there's a little bit of uniqueness, which Noah will be much more able to speak on than myself, but front end's super cool. So let's dive into it.
Cool. Yeah. Thanks, Timmy. Let's see. So it really is, not that complicated. I feel like when I was asked to do this, my first thought was really trying to figure out what would even be useful, because there's just, there's infinite things to talk about: React, Next.js, state management, like all this stuff. So this tutorial is none of those things. You can learn how to write general front ends elsewhere. But I was thinking back to when I was getting started and how poor the documentation was, and how even when I found the right functions, there was really just no guidance on how to interface with the blockchain, like how to format messages, just all the tiny little details that people kind of expect everyone to know. So I'm thinking we'll just look at the functions and look at how they're used, and then kind of point out the intricacies and go from there. So I'll send the repo of the README that I'm looking at. I wrote this up a couple of days ago. If you guys who are following along want to just go clone the repo and install the packages, I'll give you a minute to do that, and then you can follow along in your editor of choice. Let me know when you have this set up. I'll give you a minute or two. But you should hopefully all have Node installed. Hopefully Yarn, I don't know why, is the package manager that all the Cosmos projects seem to be using. I want to change that back to NPM, but it's fine. It's fine for now. I should also mention this is a Flashloan UI that Zeke actually wrote for his Flashloan contract that he went through in the last in his workshop, and I kind of gutted all of the chain queries and execution calls and made them little exercises that we'll look at. So he made this pretty front end with these cool designs and colors, and we're just gonna fill in the chain components of that, the Cosmos specific parts. All right, I think we can get started. So yeah, like Timmy said, there's really 2 functions: query, contract, smart, and execute. And then you can check out the docs and the source code for both of those. Let's just look at the arguments real quick so we understand how they work. For query and contract, all you need is the contract address and a message, which is a JSON formatted message. And then the execution call, you have to have the sender address, which is just the wallet, the contract address again, the message, and then a couple other things: fee, memo, and funds. Funds are when you're sending coins to a contract. So if you want to perform a swap, you have to give your Juno to the contract, and it'll return you the other coin. The fee, oh yeah, I can totally zoom in. Great idea. How's this? Sick. Cool. Okay. The fee, you can set a fee manually, but we always use auto because gas prices are constant, or at least constant at the time of the execution call. I think on Juno, for example, it's 0.0025 Juno. And so you set that in the setup, which I'll show you below, and then you can just set auto fee and it'll calculate hopefully the optimal price each time. A memo I always keep empty, but that might be useful. I don't think we have to worry about it in this tutorial. So setting up the clients, these are the 2 classes that will be useful for connecting to the chain. So Cosmos client, there's no signing, there's no wallet stuff. This is just for querying contracts and balances and such, just asking for data. And then for executions, there are a lot more steps involved because you have to connect to Kepler, assuming that you have Kepler installed in the window. You have to ask them to enable the chain that you're using, and then you have to get this offline signer. You have to get the wallet address from Kepler, and then you have to create this signing client. So here's the gas price I was talking about, where you set it at the beginning, and then it calculates fees automatically. This is a pattern that happens the same exact way in every single DApp. And so some people decided to abstract this into libraries like Cosmodal, which was written by the creators of Kepler, which just provides the wallet connection for you, allows you to get the address. It was pretty good. It worked most of the time. There was some wallet connect issues sometimes. So I did a little refactor of it to make it more stable and then provide some more features for you. And so this is important to understand where it came from, how to set up the clients, but honestly, I don't think you should be having to worry about that every single time you make a new DApp. So I'd recommend just using this library, my library. A note on this library is that we're further refactoring it to make it more general than just React, because right now it just works with React. But we're extracting into some core, and we'll add adapters for all the different wallets and like front-end frameworks like Vue.js that people use. So instead of having to set this all up yourself, you can follow the README on Cosmodal's GitHub page, and then you can just like use these wallet hooks in the app. So that provides a connect function for you, provides a signing client, provides the address, and then lets you just make execution calls. This is like a little like React component that you can look at. Does anyone have any questions on any of the stuff I've talked about so far? Going kind of fast. High level difference. Great question, Ikez. So Use Wallet Manager has another argument that I'm not extracting here called connected wallet that is either undefined or not. And Use Wallet just takes the connected wallet attribute and then throws an error if it's not defined. Or no, doesn't throw an error, just kidding. I figured that the Use Wallet Manager hook will be used only in the connection button component, and then everywhere else that you want to access just the wallet name, wallet address, and signing client, you'll just use Wallet, so you don't have to destructure the connected wallet property every single time. Use Wallet also has an additional feature that lets you pass in any chain ID, and then it will attempt to connect to that chain, which allows you to do more like IBC oriented or cross-chain executions. That's not going to be seen in this tutorial, but that is in the Cosmodal docs if you're curious. Cool. We'll continue, but feel free to drop them in if you want to check back at something from earlier. So we've seen how to set up the clients. We've seen how to, which queries you want to use, which functions you want to use here. Now let's actually try looking at some examples of how to do them. How to convert actually from a REST contract to a call that we want to make. This is really, I think, the crucial component. So we're taking a look at JINOSwap's swap contract. They have a public JSON list of its liquidity pools. And in that JSON, I took out the JSON, the Juno to USDC swap address, which is here on the mainnet. And you can see the query messages and the response types that we care about. In this example, we're just going to be swapping Juno for USDC, which is why we have the swap contract. So in the REST code, in the contract, there's this query message that has this specific enum variant among other variants. And then there's this response. And so with that, we can convert into this JavaScript query where we pass in the contract address and then the JSON message. So an important thing to keep in mind here is that this query message has this decorator that converts all of its properties into snake case. And so what that means is that all of the capital letters in the name become lowercase, and there's an underscore between them. And so this is the snake case version of that. Cool. And then the response is going to be also a JSON version of this response. And so we can just take the token 2 amount out of the response. Is this pretty clear? This should be pretty straightforward, I think. You're really always going to be using this function and this pattern. This is exactly what it did. Great. Okay. And then, so taking that, we can further expand that into a React component that connects to the wallet and queries the chain. And so let's see what's useful to talk about here. Without knowing a ton of React, I can explain just the use effect is a function that just calls this one time for every change in this dependency right here. So this use effect down here has these two parameters, which means it'll get called only when one of these two things change. And so what that lets us do is it lets us execute a query efficiently and store the value of it without having to execute it every single time the page renders, just the first time it renders. So here we instantiate the client. It's a query client, so we don't need any fancy wallet stuff. We ask for the wallet name and address. And then in this use effect, we want to ask for the current USDC price of Juno. And so we use this fancy get balance function on the client, passing in the wallet address. And then we pass into the query that we saw earlier. I'm gonna zoom out one tick because this is more dense. It's really important to keep in mind decibels. This is one of the biggest things, actually. Yes, seek. Empty array means it'll only run the first time. So this client gets instantiated once and then stored in this state, and then this instance will always be constant. So yeah, okay. So here's something I should explain. Let's see, right here. Juno, Atom stars, all of USDC, all of these tokens don't actually exist in the way we think of them. They exist in these micro denominations with like U prefixes that you've probably seen before. U Juno, U Atom, U stars. That's the actual like raw integer number that exists. It's like cents for the US dollar. It's the smallest denomination of currency that we can exchange. And then Juno, Atom, all the ones that we actually use on websites and DApps, and that we see in our wallets, those are like just a 6 decimal shifted version of those micro denominations. And that really matters. That actually really, really matters when you're using front ends, because when you're talking to contracts, you want to use the micro denominations. But when you're showing it to the users, you want to show the human readable denominations that they're expecting. And so this is probably the most important part for not making people spend way too much money or way too little money. And so we actually get the balance of the wallet in UJuno, not Juno. And then we pass that to the contract. And then we get back essentially a micro version of USDC that we then have to convert. So we take the response token to amount that we saw before, and then we shift the decimals 6 to the left so that we have the macro version that humans are used to reading. And then we do the same thing for the UJuno. We set the state, and then down here, we display that. I guess another thing to keep in mind here, you can kind of ignore all the noise here. I'm checking if the client and address are defined yet, because if they're not, we can't do anything. That means we probably haven't connected to the wallet, or we haven't established a client connection yet. And then use effects, you can't make this async because they have some fancy, they call like a cleanup function that's returned from this function on component unmount, which you don't have to worry about right now. But we define this async function that lets us have this nice like async await pattern instead of like having a bunch of .then, .catches with promises. And then we just call it down here. Cool. Okay. And then here's some like connection disconnection stuff just based on the connected status from the wallet manager. Cool. So denominations are really important. Keep those in mind. Other things that you will need to know and randomly pick up when you're using these contracts is that UN128, very common type in Rust contracts. It's actually a string in JSON, not a number, because it can be really large, and strings can have, a lot of numbers in them, and they're not floats. And so when we're doing this, we have to convert to strings. getBalance actually returns an object with an amount that's already a string, so we're happy there. But then we have to convert these outputs to numbers. And then those UN 128s, sorry for moving around so much, they're up here, right here. So these are actually going to be serialized as strings when you're doing JavaScript stuff. I'm going to close that. And then, yeah, snake case is important to keep in mind. Cool. Great. All right. Let's move on to execute. Slightly more complicated, but not too bad. So now that we've queried the wallet's balance, let's say we want to swap 10% of it for USDC. So again, you can check the code here and the execute message variant that we care about, which is also right here. Again, it's snake cased, so the swap is going to become a lowercase s WAP, and these are already in snake case, so we're happy there. This enum token select, because this is some technicalities about Rust, but because the Rust enums have no parameters here, like Rust enums can contain like a struct basically, they're serialized as strings as opposed to this other weird format that you'll use in other cases. Maybe you should, yeah, it's fine for now. So this input token 1, because token 1 is Juno and token 2 is USDC, just because that's how it's laid out. The input amount is the UJuno input, and min output is the output that we expect from it. So this is the message that mirrors this. Because expiration is optional and we don't care about expiring this trade right now, you can just ignore it, or you can set it to null in the message. Either one is fine. And then auto fee, undefined memo, which will just replace itself with an empty string, and then coins. And this is because we actually have to give the contract our UJuno in order for it to give us the USDC. Coins, we'll see later, is a helper function that just creates an array in the way that the funds expects tokens to be denoted. So this coin right here is just an object with amount and denom in it. And so this coins function creates an object with amount and denom in it. So let's look at the component for that. It's the same as the view balance component we looked at for the query, but it has an additional execution. And so let's see what's different. So we import coins from this Cosm.js Stargate package. That's the only difference. We get the signing client this time because we care about it. Connect the query client. We actually don't have to do this anymore because the signing client extends the normal client, and so we can query with the signing client as well. But I just left it the same because we don't want to have too much difference between these two examples. They're very, very related. Added 2 more states because we're going to calculate the balances as we did before, and then we're going to calculate how much we want to swap for. And we'll display that to the user so they don't get an unexpected amount of USDC. And then just some transaction state that we're going to store so we can display nicely. Yeah. So this is pretty much the same. We clear the state at the beginning. We get the balances we want, and we convert them to the right decimals as expected. And then we have to do this fancy math to say how much Juno we want, how much Juno we're going to swap, which is 10%. And then because we're doing floating point math, we want to fix the decimals to 6 and then convert it back to a number. So 2 fixed outputs a string, and then we'll create a number out of it so that we can do calculations with it. And then Juno swap, whenever you're swapping a token, you check the current price, and then you add some slippage acceptable because the price may change from the time that you read the price to the time that the contract actually gets executed. And so here we're accepting a 1% slippage of the 10% that we want. So we're saying if the price fluctuates by 1%, we're still happy to make that trade. And that's really the only differences here. And then we create this function. Use callback is similar to use effect in that this function definition will only get redefined when any of these dependency parameters have changed. So here's the execute call, exactly as we saw it before. We're doing some math here to convert the balances we want to swap to the micro denomination. So we're shifting the decimals to the right 6 places and then fixing to 0 and then flowing it. Same thing with the output we want. And then we pass those as strings, because 2 fixed makes a string, to the swap message that we saw before. And yeah, this all looks the same. And then if it works, we store the transaction hash, and if it doesn't work, we read the error and display it. Would that slippage bit work for both price changing and let's see if we can migrate with their own order? That's a good question. I don't think so, because we make the trade and then the pools are affected as a result of that. But I have not looked at the swap contracts that intensely. So Zeke might be able to answer your question better than I can there. Yeah, so once we have the balances, we display what the wallet contains. And then once we have the swap balances, we say, we add a button to make the swap, and then we display transactions or errors accordingly. So I think I mentioned all of this. Coins, there's also a coin if you want to have multiple coins. Coins is funny, it actually only lets you, it creates the array with 1 coin in it, but you can use coin multiple times if you want to send multiple coins to a contract. Expiration can be null. Okay, expiration can be omitted, as we saw, because it's an option type in REST. Very important to keep track of your currency denominations. Expiration can be a block height or a time, actually. So I think it's an enum with various components, and we can look at that. We can look at the source if you want to check in REST. And then it's a string, and snake case makes the swap become lowercase. Cool. Okay, so this is like, in theory, you now have all the tools you need to be able to talk to the chain from JavaScript. There will, of course, be little technicalities here and there, like the enum stuff, and there's plenty of examples that exist that will help you figure those out. You can always feel free to message me or come to the Dino Discord, and we'll figure out whatever's going on. But let's run through some exercises now that, thanks Steve for sending that. Now that we have all the tools we want. So these are actually in the code. So I'm thinking we'll just do these and we'll see them change the code. So let me share my screen instead. So let's just yarn dev this, and you're welcome to yarn dev it on your own machine. If you we have the exact same changes right now. I'm on the latest main, and there should be nothing should work right now, basically. I deployed a Flash-on contract yesterday. It was beautiful UI that Zeke made. And I provided some Juno X to it, so we can see that here. But everything else is not working. If we try to provide to this contract, it asks us to implement the call. We can't actually see. Yeah, okay, nothing's working. So we'll start with the first exercise, which is just getting the fee. And where does the fee actually show up? And that's something we should have figured out. Oh, it's in the docs. Okay, so right now fee is 0. Cool. So what we want to do is get the fee from the config query, so we can tell the user how much their smart contract needs to return of the flash loan. So just a brief overview of the way flash loans work. You basically get as much money as you ask for 1 block, and if the flash loan contract does not receive the amount that was loaned plus the fee by the end of that block, the transaction rolls back and nothing works. So here we want to display the user the fee so that they know how much to program their contract to return in their loading action. So we have this get config function from the REST that you can see here. I linked to it. And then we have this config response that's also visible right here. And so now what you should do is write the query in JavaScript, having this message and this response expected. We want to get the fee. How do we get the fee? I'll give you a couple minutes. That's Rust, because wrong language. Okay, we're gonna look at the solution. Here it is. Crazy. Get config becomes snake cased like this. There's no parameters, but we still have to make it into an object. And you just get config.fee after you get the config response. This config, the response for a query becomes immediately the deserialized JSON version of the struct. Cool. So now let's go and put that in the selector and see what happens. Copy this. Decimals are serialized as strings. Yeah. So let's put that in where the selector is contract. So this selector system this recoil is a state management system, like I mentioned at the beginning. Don't have to worry about that right now, but it's definitely something to learn to write front ends that manage state efficiently and cache things. So delete this to do, put this config in right here. Boom. Let's see what happens. 105%. Yeah. Perfect. The fee is 5%, and in the fee component, it says it adds 100 because you have to return 100% at least of the Juno Len, or Juno X in this case. Great, so it worked. So we literally just asked the contract for the fee. We got, if we want to check it out, we can check out the config response. God, so many errors. We're gonna refresh this. Cool, so we got the admin, which is the address that I created this with. The fee is 0.05, serializes a string like we saw. And then loan denom is the other config property, which is which denom loaned in. Cool, great, so it worked. Let's move on to the next exercise. This one is slightly more complicated because you have to actually pass, let's see, possible style enabling wallet modal. It is possible, and it will become more possible in the future when we're doing this. This refactor they're doing right now. Right now, if you use Tailwind, you have classes, you can pass a bunch of class names into the modal and change stuff. Yeah, it looks pretty rough right now for sure. Cool. Okay, so here we want to tell the user how much their wallet has already provided. So right here, I provided 3, but it's saying -1 because we're not asking for how much we provided. And so, yeah, we'll query for the provided response of the wallet address that we have. Assume we already know the wallet address, and we just want to, get the provided amount. There is not a custom struct response defined in the state or in the message files in Rust, and so we actually have to turn to the query function itself, which is right here, the query provided. You can see it takes the wallet address that we pass in. And so if we just break this down a little bit, we can see that if it loads a provided a provision, it will just return the binary representation of that value. So just a note, another thing that you'll pick up, all queries are converted to binary before responding. And so that's just, you can kind of ignore that when you're looking for the return type because the actual data being returned is this. And then we have to look at what provisions type is. And so we find it in the state file, and it's a map of wallet address to UN128s. And so we know that this, we're loading, given the address, we're getting the value of UN128. And if there's no provision found in this map, we just return 0 number. So knowing that UN128 is serialized as a string, And knowing that this query returns directly just a stringified number, write the query. Maybe we'll speed this up here. Nice. Yeah. Yeah, awesome. That's exactly right. Crazy. Yeah, you went a step further and you converted it to a number. It's freaking awesome. So provided becomes the key, lowercase because of the snake case, and the address is just a property for wallet address. Cool. So let's go put that in and see what happens. Contract 48, right here. So this selector returns a string actually, and let's see where it's used. Go to right here. So there's this conversion function that is just a handy utility method that Zeke wrote that converts it, shifts at 6 decimals. So what you put was correct. It's important to keep in mind that this returns u Juno or u whatever denom, and then we have to shift it ourselves. So if we put that code there, and then we can go check, and we see that I provided 3 u Juno X. And if I disconnect my wallet, then nothing, because there's no wallet address to query. Cool. All right. Third exercise. Now we're moving on to executions. So we want a loan. We want to make a loan. Assume we have all the addresses that we want. How do we write the execution function with this loan execute message variant so that we can tell the contract to give us a loan? An important thing to keep in mind is that executions don't have a response like queries do. So there's just a common response in the Cosm.js package in the signing client that will return like the transaction hash and the logs and a few other things. But it's always the same, so we don't have to worry about the response. Yeah, Cosmodal. The whole point of Cosmodal is that it's a modal that lets you pick Kepler or Wallet Connect. So if you just implement Cosmodal, you'll have mobile support by default. The actual core of Cosmodal is like allowing Wallet Connect to seamlessly replace the Kepler connection, because there's like an annoying amount of code to do for that once someone's figured out, no one should ever write again. And yes, we will support more wallets in the future, hopefully in the next couple of weeks. The adapter system will be ready to use. And yes, Leap Wallet. Yeah, we're talking to Leap Wallet guys. They're involved in the creation of the adaptable project. Yeah. If you guys want to help out too, we're in a wallet DAO in the DAO Discord. And this one actually, I don't think we'll really be able to test in the UI because I didn't set up a contract to perform a loan with. So we have these parameters. We have the loan function that's snake cased as always, the receiver address, and then the amount. So this amount, I want to do some fancy stuff where we convert Juno amount. We shift it. What are we doing here? We're shifting it to the right 6 decimals to make it in its smallest denomination, and then we're converting it to a string. I could have also used 2 fixed 0 here, which we used earlier. Either one, it's fine. Fine because we floored it. That's why it's fine. And then the fee is auto, like we saw. And then we left out funds and memo because we didn't send any money, and memo is default empty string. Cool. Now we can actually, so I'll put that in just so the code is happy with us. Next one. Now we can actually test this one. Let's provide the flash loan contract with some Juno from our balance so that it can make loans. So we're going to have to do some fancy number stuff with the Juno amount, and we're also going to have to send the contract money. So we might want to use the coins function. How do we provide the contract with money? This lavender kombucha is really good. I highly recommend. I'll give this one 30 seconds. Running low on time here. Cool. Let's check it out. So we have the coins from the Cosm.js Stargate package. We have our inputs. And yeah, so we provide. Oh yeah, I should have read that. Oh, that's next. Yeah, all right. You spoiled it. Okay. We use the coins function again. We convert Juno amount to U denomination, and then we convert to a string. And yeah, this is the execute file. Looks pretty standard. Yeah, so now the market is down and we have to pay rent because we live in late stage capitalism and life is hard. Let's withdraw the Juno that we just provided so that we can survive. Assume you know the wallet address. Here's execute message. Looks pretty similar to all the other ones we've seen. I'll give like 30 seconds if anyone wants to do it. Actually, no, it's fine. It's the exact same. Here's a solution. You just call withdraw with no parameters and auto fee as usual. And now we have a fully working Flash Loan UI. This actually, you can just use this now. Let me paste these in and we'll try providing and withdrawing. 114. Oh my god, I didn't even pay attention. Amount, import coins. Validate amount, cool. And the other one. My Flash Loan fee is one Flash Loan, so you'll actually have to give me 2 Flash Loans if you want to make that trade. Sorry, yeah. Okay. Cool. Let's try it out. So we can see how much we've provided. We can see the fee is still there. We can provide another one. See what happens. Oh, failed. Juno is smaller than. Oh, we in. What? Oh, yes, of course. I'm using the wrong denom. Make sure to keep those. Yeah, I know that error looked horrible. Let's look at that again. This is like the worst part, is that you get these crazy Go error stacks. And all you care about, this is actually probably a good thing to know, all you care about is the last line. That's where the actual error message is. And these are notably difficult and annoying to parse. So let's change that to Juno X to make sure I didn't make the same mistake in the other code. I don't think I did. Cool. All right. Try that again. 1, provide. Whoa. Prove. Whoa. It's working. That cube is spinning. Oh my god. And we provided 4. Now we provided 4. That's crazy. That's absolutely crazy. And now, right, the market's down. We need our 4 Juno X or else we cannot pay rent. So we'll withdraw. That cube will spin. We'll approve this transaction. And let's see. Let's watch our balance go up. 5.9 right now. Now it's 9.9. Hell yeah. And here's our transaction hash and everything. And we did it. We freaking did it. Now you can talk to the chain. You can tell the chain to do stuff. You can, I don't know. You can make infinite money pretty much. Cool. So go off and use this knowledge to make the world a better place, please. Please. Yeah. Sick. I'm going to leave this as empty. I'm not going to commit those changes. That confirmation that pops up. It was a copy. Yeah, that's just something Zeke implemented in the Toast, the pop-up library. There's nothing fancy about that by default. Success Toast. Success Toast. Wait, where's the transaction toast? How is it? Could we add them in scan linking? Oh. Yeah, pretty easy. Yeah, let's do that. Let's add. So I'm assuming transaction hash is already in the right place. It's there. The icon for the toast. Okay, great. That's crazy. The icon for the toast is actually a component and not an icon. That's great. Let's add a little external link icon, and we're using this really nice hero icons package that we use in DAO. It's really sweet. Text white, and then we'll make this. Ooh, actually, we should probably. Yeah, this is fine. No, we gotta make this. We gotta make 2 buttons because that button's gonna conflict. So in React, what I'm doing right now is I'm making a fragment that lets us like put 2 components next to each other without like being immediate children of anything. So we'll make this a link, and then we'll link to the mint scan in a second. We'll make this. Let's chill. Target new window, and we'll put an icon in the middle. And now we should. So I think does Mintscan have testnet? I'm pretty sure it doesn't, but I think I use like pub dot. No, what is it? Ping pub. Yeah. Okay. Mintscan does, really. Oh, for Juno, not Juno X though. You're saying it does. That's so crazy. That's so crazy. Okay. All right. Freaking awesome. So I think it's just /tx/ let's make sure that the transaction URL is just, yep, /tx is. Wow, this is not common. Okay. Thank you guys. Awesome. Let's throw that in right here. We'll replace the transaction hash with hash and hope that works. So we'll provide, let's just see what happens. Execute this. Nice. Click that. Boom. Boom. Transaction. 3 U Juno X, which is 3 million U Juno X, which is 3 Juno X. Like you can see right here. Cool. Yeah. We can put it in an envar. Exactly what we should do. We should always put these things in envars. So now we can say transaction prefix, mint scan transaction prefix, go to the constants file. And then we'll just take that. And then we can stick that. Stick this in the end file for testnet. And then in the end file that we're using. And then we can stick one in mainnet for let's see. Mint scan /tx's. Yeah. Mainnet we got right there. Cool. So now if you just whichever environment file you choose, which you can just replace this .env contents with one of these two to use mainnet or testnet, it'll just automatically switch this prefix and everything will work like magic. And we'll import that. Don't know why I named it like that. Import that from constants. And let's try it again. Draw. And pour again. I think I had to restart the Next.js server. This is probably not going to work. Yep. Well, there we go. Yeah, so I loaded the environment variable from that .env file. And only on startup. Sick. And let's just see if mainnet will. This will be happy. This will be nice to us. I think this contract is real. Pretty sure I made that real. Let's see, do I have any Juno in this wallet? Nice. Let's provide one more Juno. Nope, I can't. Oh, it's confused. Oh no, I hard-coded a denom. This is a great example of why you shouldn't hard-code denoms. Sick. We already had it. Could have just used it, but I didn't even think about it. Let's try that one more time. Nice. Now we're on real minscan, real Juno mainnet. One Juno. Look at that. Look at that. Cool. Never hard code. Could we style a Cosmodal? We could style a Cosmodal. Let's freaking do it. That's such a good idea. We got time. Do we have time? Does this just time matter, Timmy?
Nope, as long as you've got time.
Okay, all right, cool. Let's see what we can do. Right here, this is so we didn't look at this. This is the Cosmodal setup. So instead of having to, this will once you give it these properties, which I know it looks like a lot, but it's really not that bad. All that signing client wallet stuff is just provided for you. So if we look at the page, just look at this real quick. We have this wallet manager here where we connect with the button, and then when we provide, we retrieve. Oh, all right. Well, I see. Zeke didn't even use the use wallet hook. That's okay. Connected wallet is equivalent to use wallet, except it can't connect to other chains. So this works fine. We have connected wallet address everywhere. And so we can see here, this is like the mobile wallet connect meta that will display when you try to connect to the page. Actually, that's fine. And then enabled wallet types. Right now there's just two, Kepler and wallet connect Kepler. A loader for the modals. Providing a local storage key will make it auto connect on refresh, so I don't have to keep connecting every time. That's a common pattern that was tricky to get right, but now it works and we can just forget about it. Default chain ID, which is taken from the environment variables, which is right here. There's also a chain info ID enum that you can just connect to any of these chains that we've stuck in there, which is awesome. So you don't even have to worry about chain configuration. And then this is the gas price that lets us use auto whenever we make an execute call. And so we're going to add another one that's, what's it called? Class names. And let's go check the type of that thing. Nope. So weird. This is all the stuff we want. We'll just replace all this with some strings for us. Cool. So now we can change it up. I guess because you probably know all of the classes to use. Point me in the right direction. I'll probably want to make them all like similar rounded squares like this. BG card might be a good one. Interesting. I'm putting this back on mainnet. Or testnet. Card. No idea where. Somewhere there's a colors. Okay, cool. That's fair. Oh, I can't even connect. Oh my. Oh my. Okay. I think I just cleared the classes. Oh, this is great. Okay, now I can just mess around with it. Modal content. BG card. Nothing happened. Alright, let's try overlay. Still nothing happened. Or maybe it needs a little important. Oh god. Why? Let me let's look. I'm gonna look what the DAI UI does. We're just gonna copy all this and then we're gonna change stuff because this I think is a good place to start. Okay, so overlay is just the background, so we don't really care about that. Content looks like we can do stuff like, okay, BG card is transparent. I'm so confused. We'll check the colors. Yeah. Oh, interesting. Yeah, okay. These are the relevant. Split down. Wait. No, I'm gonna hide that. We're gonna split this down. Okay. This is good. What's going on here? Why are things so weird? Why is this transparent? Let's do a little inspection here. Dash card. Oh, maybe it's not. I wonder if the colors are defined not here. Like, you said class in the whole container. Yeah, okay, that's cool. So which one should we use? Loan, provide, or docs? We'll do loan because we're on the loan page. So maybe here I can do loan. It'll all magically work. Yes! Holy shit. Let's add it to the, let's do provide. There might be nicer colors right here. Interesting. Don't need a border. This is getting kind of crazy. Let's see, primary title text. Accent, I can't see the chat, by the way, if you're messaging. Would be cool to match the page. Would be very cool to match the page. Where are those things defined? Loan, background. Where to put this? If only there was a way. Oh, we can check the router path. We can use the router path. So Next has this router that has this as path function. And I think if we try, that was a really bad idea. Never alert anything. There's gonna be so many. Yep. What's the path? Slash. That's not good. What's the, maybe there's like a page name we can get. Or something. Path name, maybe. Well, let's just look at the entire router. I want to get like the file name or something. Components. No. Okay, well. We can just, we'll just get the anything after the slash, and then if it's empty, we know that it's going to be Yeah, that's gonna be the loan page. So let's try that. Right, docs, great. So we can take path name and stick that in here. And that should make things really nice. Oh, I'm sorry. Oh God. Okay. Text content. What is text content supposed to be? Title. Text white. All right. So this all looks like that. I kind of want this background to be that. To have that background. That nice, that sweet background color. We have BG background. Awesome. That looks good. And then these can be, yeah, this looks so good. Oh my God. And then we'll make them less round, I think. Rounded just a little bit. What else? Wallet. BG card. Rounded just a little bit. What else should we do? Text. Fix all the text. Do we have any other, what's this? Text dash accent. That looks kind of weird. Looks really weird. I'm starting to really like this though. Let's make the close button white as well. How do we do that? Let's see how the close button is styled. SVG, current color. So we can just set the text color. So SVG, if it's set to current color, we can just set the text font color and it'll change. Ah, this is so good. Maybe we can make that accent. Yeah, that's weird, but let's jump. We'll change this not to accent. Maybe gray. Maybe light gray. Maybe white. Maybe white with an opacity. Yeah, I like that. How's it looking? How do we feel about this? I want to make any changes. Any suggestions? All right. Oh, the font. Oh my God, the font. That's what's missing. Where's the font being set? Studio. Shouldn't it just by default be that? Why is it being all like this? Where do fonts get set? Oh, font dash header. Okay. Where's the time? Yo. I feel like applicates it too. Yo. Oh my God. This is sick. No, maybe there's no subheader here. Maybe this should be here. Oh my God. Maybe this can be not. Yeah. Hell yes. Hell yes. Okay, let's try changing the page. Yo! No way. This is so good. And we probably can't play this on here, huh? But I want to see it with the docs. Let's just check. Let's add a connect wall button to the docs page so we can see it. Where's the connect button? Nice. We're gonna replace this action card. And then, we need the connect button function. So we'll just use a wallet in here. Use wallet manager. Connect. Sick. All right. I think that's pretty good. I think we've, yeah. So that's a Cosmos front end. I hope that was helpful. That tutorial will always exist on the README. And it's pretty self-contained. WinPR. yeah. We'll make a PR. This is great. It's freaking awesome. Thanks everyone for coming. Any questions? Any Q&A? I'm happy to be here for a few more minutes. I do have to go. I'm going camping immediately after this, so I'm going to dip in the next 20 minutes or so. But if anyone has anything.
If anyone wants to unmute your mic, I think you'll just have to leave the channel and hop back in. Everyone has permission now if you do, or just keep it in the chat. Either way, your call. Maybe you should have done this at the beginning, but Noah, take a second to shill yourself and what you do. I feel like you're not too active on Twitter, so some people might not even know that you're part of the DAO team, for example. But
yeah, I never have an instinct to talk about myself. I work mostly on DAO, primarily on DAO. I'm doing some other things, but mostly either as a result of DAO or building on top of DAO, some cool things. Zeke and I worked on DAO Up back in March of this year before we decided that we needed to make a change to it and shut that down for now. But yeah, I don't know. What's there to talk about? I like building things. Right now, I really like building DAO because it's freaking awesome. And yeah, that's so funny. Yeah. It's really not that much to say. Yeah.
No, that's plenty. Yeah, this has been awesome. I feel like no questions trickling in. As always, though, we'll get this up on YouTube, and you can always chat in our Discord here. There's a bunch of builders that kind of hang out. So if you ever have questions, someone will probably get back to you at some point. But yeah, this was awesome. That was super cool, Noah.
Thank you
so much.
Yeah, of course. I'm here to help. Feel free to slide into my Discord DMs if you have a question. That, getting started with this stuff there's just so many small things, and there's really no stupid questions. So don't feel bad for a lack of knowledge.
Everything in Web3.
Yeah.
Cool. All right, guys. Well, thanks everyone for showing up, and anyone who's seeing the video here, give a subscribe to the channel. This is the last workshop of this campaign that we kind of have planned, but there's been both demand and offers from participants and instructors alike to do more, so definitely stay tuned, and we'll be getting some more education out there. Cool.
Education, yes.
Woo! All right, everybody enjoy their weekend, and we'll catch you in the next one, whenever that might be. See you guys.
Later.